Okay, we're going to solve the next exercise. The exercise is the number 1.23. First, we're going to read it. The 1 feet times 1 feet times 1 feet cube of iron weighs, this is a pretty important word, 490 pounds at sea level. Determine the weight in newtons of 1 meter times 1 meter times 1 meter cube of the same material at sea level. Well, first, what we have to notice here is that we are going to talk about a weight. So a weight is a force, it's not a mass, because a weight is given by as I just said, a force, which is equal to a mass multiplied by an acceleration. So I know that this could be confusing for the ones that are not used to manage this kind of information, but let me get this straight for you. When we talk about a mass, then we have two different options. Talking about use customary units. Actually, the whole name would be use customary base units, and the international system units. There is actually more types of units, but these two are the principal, are the most used ones on the planet Earth. So when we talk a mass in use customary units, then we are talking about principally about slugs. This is a kind of unit, so there is not mystery there. You have to maybe use a mass in the use customary units, then you use slugs. But there is also one other unit, which is the pounds. So when we talk about a mass in use customary base units, we could talk about the slugs or about the pounds. In the international system units, that is more like easy to understand. Why is that? Because the mass is given in kilograms, and that's it. Remember that this K is actually a prefix, because the unit is the gram. Alright? Maybe let me get this straight, because let me do a parenthesis here. A prefix is a letter that change the value of the next letter that follows, or actually change the value of the word of the letter that follows. In this case, the G. So you can Google prefix. Actually, I don't know if I'm missing a F here. Well, I don't know. You can Google prefix chart, and there, let me just get back to the exercises that we have done previously. You will find this chart. Copy and paste. So as I was saying, you'll find this chart in which every single letter is a symbol. So in this case, the letter K, which is kilo, will mean that the grams that I have right here, for example, I have, I don't know, 5 grams, I have to multiply it by times 10 to the third power, which is this one. So 5 kilograms are going to be equal to 5 times 10 to the third power grams. Alright? So, for example, I don't have a kilogram, but I have a megagram. That is not that normal to say, because every single mass is given in kilogram, but it could be also given in megagrams. So megagrams. Then I have to find the chart, the letter M, or the symbol M, which means mega, and which means that I have to multiply the value by 10 to the 6th power. So the answer would be 6 times 10 to the 6th power grams. Alright? So how do you memorize this table? Because you have to memorize it. You don't have to, actually, if you are on the field or if you are in a place in which you don't have the table like next to you, or you don't have access to the table, let me give you a trick to remember it. First, you gotta memorize this prefix, these words. There is not other way. Kilo, mega, giga, tera, peta, exa, zeta, iota. I always remember till this one, because this is 2 are too much, but you have to remember that these two actually exist. And then I have here deca, deci, centi, milli, micro, nano, pico, femto, atto, septo, yocto. So as you notice, I've divided the table chart in 2 sections. The first one is this one. So I'm sorry. The first one is the upper side of the table and the below part of the table. Then deci will have the value of 10 to the minus 1 power. Centi, in that order, to the minus 2. Milli, to the minus 3. And starting from that point, I'll add 3 by 3. So minus 6, minus 9, minus 12, minus 15, minus 18, minus 21, minus 24, etc., etc., etc. And on the upper side of the chart happens the same thing. So 1, 2, 3, and starting from that point, 6, 9, 12, 15, 18, 21, 24, etc. This is the way I've memorized it. So you don't have to use it. If it works with you, that actually makes me happy, because that is why I'm taking this time to explain to you this chart. But well, now let me continue with the explanation of the units. When we talk about a force in the US customary units, we will have to talk about a pound. But this pound is given as a force, as I just said. So for me to recognize it, I always put an F next to the B. But some books, as we've seen, don't use that F, but they tell us that we are talking about a weight, so we have to read carefully. In the international system units, that is more like easy to understand because we use the newtons, and the newtons are given, or actually are a force, and a force, as I've been saying this whole time, is equal to a mass multiplied by an acceleration. So in the international system units, we will have a newton, which is a kilogram multiplied by a meter per square seconds. Alright, so the same thing happens here, because a pound is given by a slug multiplied by a feet divided by square seconds. Alright, so in the international system units, we also have something called force kilogram, but we are not talking about that because that is pretty confusing. But it is important for you to understand that there is also a unit which is equivalent to a force pound. All right. So now that I've made that clear, we can continue with our exercise. So we have 490 pounds given in a shape which is 1 feet to the third power. All right. First, we have to evaluate an equivalence. Why is that? Because they are telling me 1 feet times 1 feet times 1 feet cube weighs 490 pounds. So this is equivalence. Every single feet to the third power, I'll have 490 pounds of weight. All right, and now I have to transform that and get a relation in which I'll have 1 meter to the third power, and I'll have an answer in newtons. All right, so the first thing that we have to do here, and the only thing that we have to do here, is to change the units, to do some units conversions. So this is equal, as I've explained before, to 490 slugs times feet divided by square seconds. And I'll have here 1 feet to the third power. First, let me change the upper side of the division. I mean the numerator part of the division. I'm going to multiply this by one slug and transform those into kilograms for me to eliminate the slugs. That is why I'm putting the slugs on the below part of the division, for me to eliminate these slugs. And I have to write here an equivalence. So 1 slug is equal to 14.59 kilograms. How do I know this? Because I've memorized it. You can Google it, and maybe you can search it, but you don't have to memorize all the equivalents along the different types of units. You just have to memorize some of them, and then you play with the units. So let me continue eliminating actually units. I'm going to eliminate the feet and transform those into meters. So the answer would be 1 meter is equal to 3.281 feet. Alright, and finally I'll have the result on the upper side of the division, which is this one, in kilograms multiplied by meters divided by square seconds, or well, what is the same thing, newtons. Alright, now I gotta change these feet to the third power. How am I going to do this? I'm going to multiply this by feet and meters, and as I just did here, 1 meter is equal to 3.281 feet, but this 3 is pretty important because I gotta evaluate the division to the third power. If I have a 4 here, for example, if I would have, for example, 4 here, then I have to evaluate this division to the 4th power, and that applies for actually every single number that I have here. So the answer would be in meters to the 3rd power. Alright, and by doing this division I'll have the result that I want. So let me write this whole thing on the calculator. So 490 times 14.59 divided by 1. I don't have to write that, but I want to do it because maybe you get I don't want you to get confused along the way. So 1 divided by 3.281, and this whole division is 1. Then I multiply this by, open parentheses, 3.281 divided by 1 to the 3rd power, and the final result is 76,959.7826.9. Newtons per square meters to the 3rd power. Alright, so I could use this same prefix and change the value of the answer. So this is equal to 76.9597 kilonewtons per 1 meter to the 3rd power. Alright, so that means that a cube, which is 1 meter times 1 meter times 1 meter, would actually weight 76.959 kilonewtons. And this, guys, is the answer. And that's how this exercise could be solved.